So number 13, it says it has two x-intercepts and then wants to know the difference between them, essentially the distance. How do you find those x-intercepts? We've done this a fair bit. In here. What do you think? Yeah.
I know what x is. Like,
essentially, but what is an x-intercept also called? No. Let's think about this is a quadratic, so think about it like looking like a parabola that crosses the x-axis 2 times, they tell us, right? So what's another name for that? I mean, we've done it so much, I feel like it shouldn't necessarily need to be looked up at this point. I think this particular one is on the other side, actually. Well, so f is a function, that's what it stands for, but it's just notation that basically means the same thing as y. Okay, so what is true where these x-intercepts exist? What is true about y? It's 0, right? So if we set this equal to 0, now what do you do? Because we literally have done this a whole bunch of times. Maybe you're just not recognizing it. Star, try to, right? If star doesn't work, we wrote the quadratic formula last week and we worked with it a little bit. But star, right? That's your go-to for this. What goes on top? Well, but it's a times c, right? And what is a times c? It's 4. Okay, what goes on the bottom section? B, and in this case, b is 5. What goes on the top of these two sides? Good, a. And a is 1. And then what goes into the bottom of the sides? Description-wise.
the numbers that multiply to get 4 and add to get 5.
So, yep, numbers that multiply to make the top, which is 4, and add to the bottom, which is 5. So, numbers that multiply to make 4 are pretty short. It's either 1 times 4 or 2 times 2, right?
1 times 4.
So list those. If you're struggling to think of them, go ahead and write them out. Well, only one of those can make 5, which is 1 times 4, okay? All right, and then be careful, because are these, if I write them out, it's 1x plus 1, 1x plus 4. So when we answer this as intercepts, is it 1 and 4? What do we have to do with those things? Remember, we have to split this up and say, hey, either that's 0 or that's 0, right? So this becomes x plus 1 equals 0, or x equals -1. And then x plus 4 equals 0, or x equals -4 when you solve. Right? How far apart are, those are our two x-intercepts, -1 and -4. How far apart are those? They are 3. How many of you got that without guessing? Correct? How many of you feel like you should have now that you see what it does? Like we've done this a lot, right? Why do they write it like this? Why do they say what's the distance between them? Why do you think they do that? This is an SAT answer trick. It's not because we care necessarily how far apart they are. But it's because they don't want you to be able to just plug answers in and guess. That's why. If they just gave you -1 and -4, you could just plug them in and see if they work. But in this case, because they give you a subtraction problem, really, then you have to actually solve for them. Alright, on this one, this is a line, and that's a line. Both of them are lines. So when we have a system of two lines, what are we looking for to give the solution? Let's say it's like this. What do you look for graphically? What do you look for to find the solution of that? It's where they cross, right? Where they intersect each other. So that would be that point. That is the solution. But this one's saying no solution, which means what? They never cross. If we have no solution, then they can't cross, right? Which is a description of what kind of line? If they never cross. Say it. No, not specifically. Because you're in a geometry class, we spend a lot of time talking about lines that never cross, and they have a name. We did a lot with them that looks like this. All these angle things. What are those called? They have this symbol. I'm going to get you in a second. They're parallel, right? It's so interesting sometimes how when you switch context from geometry to algebra and you just see issues, it's kind of weird. They never cross, they're parallel. Okay, but in algebra world, we don't have a graph. We don't need it either. What do you know about the equation that makes two lines parallel? What is true about the lines themselves when they are parallel? Same word. We studied this too. When you were trying to prove if we had a parallelogram or like a kite, all those coordinate proofs, you had to actually pick out slopes and check if they are what? No, parallel? You can't have parallel. The same slope, right? Think about hiking up a mountain. Okay, here's our mountain. Or whatever. So we're hiking. If you and somebody are hiking with, they're on the same trail and you have the same slope, right? They're parallel, like you're walking parallel to each other. Are you guys taking SAT? How many of you are? This is a pretty common question type on there. How do you know the slope? So we've gotten this far. Parallel means same slope. How do we know the slope? Yeah.
Is it y equals mx plus b?
Okay, if we could write this as y equals mx plus b, which letter in there is the slope? It's m. Okay? So how do we get y by itself? This is what it says in case you can't read it. Guys, get y by itself.
Subtract x from y.
What has to go for y to be by itself? Like just literally what has to go, not how, just what has to go for y to be sitting there by itself. Negative 3x. How do you get rid of negative 3x? Add 3x. Okay? So do you see how this is 6 plus 3x? Okay, what's the slope in there?
3.
Remember, it's the one with the x. It's mx. Even if it's over there, it doesn't matter. It's mx, not m. It's not bx, right? So mx, so slope is 3. All right, do that with the other one too. So ax plus 2y equals 4. Let's get y by itself. How do we do that? Silvana, tell us the first step. Well, not just x. Remember, a, it says, is a constant. A just is a number. That's what that means. Just like this 3, or the negative 3. So how do we get y by itself? Yeah. Subtract AX on both sides. Now what?
Divide the two.
Yeah, it says 2 times y, so divide off the 2. You gotta make sure you divide everything, not just the pieces. Okay, who cares about this 4 over 2 because it's not part of this, but tell me the slope of this one. You're not going to be able to tell me a number, but tell me an expression for the slope. Do you see how it's still in front of x like it was before? Okay, which is what? Just the slope, not the whole form, just the slope. Like over here, the slope was 3. Okay, keep going.
X.
Do you agree it's just negative a over 2, right? It's the thing out front of the x. What does negative a over 2 have to be the same as for these lines to be parallel? Right. Isn't it this? That was the slope of our other one, right? We said same slope, so this has to be this for them to be parallel. So I should write here slope is negative a over 2. Right, so basically you're just, all this boils down to solving that little equation. So raise your hand when you can tell me what a is to make that true. Okay, go ahead and say. It's negative 6. Why negative 6? Yeah, if you multiply both sides by 2, you'll get negative a equals 6, and then we have to get rid of the negative sign. So a is negative 6, just basically change spots. What do you think of that one? For a multiple choice question, you have probably 2 minutes. You know, I don't know. How about that? I forgot how long it is. Hi.
Hi.
She definitely needs to go to the office. Thank you.
You're welcome.
Any questions on that one? Okay. Same slope, parallel. Parallel, same slope. Everybody say that. Same slope is?
Parallel.
Parallel is?
Same slope.
How do you find the slope from an equation? Can you put your computer away? How do you find the slope from an equation of a line? No. Get it in slope-intercept form, get that y by itself, and then there's your slope, right? It's mx plus b. Okay. Next, I'm going to give you a quick chance to review that. So write all 3 trig ratios for each acute angle. But look here at this one. The 2 acute angles are the same, so I don't want you to rewrite it over again. Just write it once. But let's do a quick review of SOHCAHTOA. Did anybody ask your family about SOHCAHTOA?
No.
Seriously?
I went straight to the
Did you get on the online dating site to find SOHCAHTOA with long brown hair? No? Maybe I'll help you look. What does SO stand for? Yep, and just as a reminder, don't forget theta. So opposite over hypotenuse. Abbreviating, of course. Okay, what does K stand for? Adjacent. which means next to over hypotenuse. TOA. Good. All right, so let's do sine of 45. Remember, again, don't forget to put your angle. So I'm just going to pick this one. It's the same going both ways, so it doesn't matter. Okay, sine is opposite over hypotenuse, so 1 over root 2. You will see this as root 2 over 2 because of that rationalizing the denominator thing I told you about. Okay, cosine of 45 is the same, but it's adjacent now over hypotenuse, but it's the same in this case. And then tangent of 45. So opposite over adjacent, 1 over 1, which is just 1. How'd that go? Just as a quick review of the definitions. Okay. Are you ready? Do you feel like you're ready to start solving? Let me kind of get, I guess you probably don't necessarily know what that means, so I'll give you an example. You don't need to write this down. First of all, remember that trig ratios require a right triangle, so if you don't see that, don't use one. Students mess that up every time this class goes through, so somebody does, so make sure it's a right triangle before you use these, okay? Alright, so here's an example. Let's say I tell you this is 32 degrees and this is 8, and I want these two sides. That's one way that we will solve. Okay? Another way, let's change the problem entirely. Okay, solve for theta. Now we're solving for an angle. Okay, this one was side lengths. This one was an angle solve using side lengths. Okay, so that's what these will look like. There's obviously going to be more than just here's a triangle solve for stuff. We're going to use this outside, like literally we'll go outside like I told you. We'll use it on paper with these applied problems. But what do you think? Feel ready? Let's see if you are. Okay, I want you to set up the ratio. Let's just give you a chance to try this. I'm not asking you to do the solving, but I want you to set up the ratio that you would use to solve for x. Okay? So set up the trig ratio that would allow you to solve for x with what's given there. I'm going to give you like 15 seconds. Okay? So do you agree the known pieces are 8 and 32, 8 side length, 32 angle? Okay? And we want to solve for x. So we need one of those ratios that relates those three things. So this is where you're going to start practicing using SOHCAHTOA to help you. Okay? So think of SOHCAHTOA. And for this 32 that was given, what is the 8? Like, name it. Is it adjacent, opposite, or hypotenuse for the 32? It's adjacent, right? So this is the adjacent side. And remember, all of this is relative to what we're given. 8 is adjacent to the 32 we were given. It's not adjacent over here, but to the 32 we were given, okay? And then what is x called? That side? Yeah, that's the hypotenuse. Okay? So you know AH. Which one is that? Well, sorry, you don't know that. You're given A, you're solving for H. Which one is that? out of SOHCAHTOA, which one is AH? That's ka, right? Cosine, SOHCAHTOA. Okay? So we write this, so cosine of theta is adjacent over hypotenuse. Eventually you won't have to necessarily write those, I think. You'll probably get it where you don't need that. Okay? In here, what do we know? Do we know theta, adjacent, or hypotenuse? We have to know two of them, otherwise we can't solve with this. Okay, so what does theta become? What is adjacent? It's 8 over x. Okay? So that's what these equations, that's one version of what these equations will look like. So now my question would be, how do we solve for x? Like, how do we get that by itself? Okay? We'll talk about that in a bit. How do we set this one up? So I'm going to give you another 15 or 20 seconds to set it up to solve for theta this time. And you know what? Just to try to mix it up a little, because I put it the same way, let's put the 4 here instead. Okay, so basically you're asking what relates those three pieces? So, ka, or toa, which one of those relates those three? Well, here's theta, that's the angle that we're solving for, so we have to use it. What is the 4? The name of the side length 4 compared to theta? It's opposite, good. And then the 10? That's the hypotenuse across from the 90. Okay, so I'm looking at this, I see OH. So which one is that? That's sine. We're going to write sine of theta equals opposite over hypotenuse. And then what, again, just like always, when you have an equation like this, you plug in what you know. So what do we know in here? Yeah, I leave theta, that's the variable, that's what I'm solving for. And I plug in opposite over hypotenuse, so 4 over 10. And then we have to go solve for theta. These are the two general types of solving that you'll get with these trig ratios. Solving for either one of these two positions, so for a side length, or solving for an angle over here on the other side. Okay? This, well, both technically you'll need a calculator to do. So that's why I'm asking you to have yours set to degrees. So do you see why yesterday's work was important? So you're used to setting up the ratios. And now we're just, instead of having known values everywhere, we're just plugging in an unknown or a variable. What do you think? You ready to try this? Okay, we're going to start with the top example of solving for a side length. Because it's not that the bottom is harder, it's just weirder because you've never done it before. The other one you have. So grab your notes, let's go start with an example in there. It's weird that this is our first example. Alright, so go ahead and get that written. So step 1, you need to know what? Is it a what? What? Right triangle. Emma, did you say that? Right triangle. Because if it's not, you can't do this. Not this way. You also can't use Pythagorean theorem. You also can't use special right triangles. So if it is not a right triangle, your options are much more limited. Anyway, I'm going to put that as step 1, but I need to Where should the 1 go? I guess after the stars? Does that make sense? That squeak is sure annoying. Okay, next. Oh.
What?
I forgot to draw the picture. We don't even have a problem to solve. Sorry about that. That would be helpful. And put your degree symbol on that 25, so 25 degrees. Okay, first thing to note is you can't solve for this with Pythagorean theorem. Second thing to note, you can't solve for it with special right triangles because it's not a special right triangle. So we are really only able to do it this way. Okay. So our next, after checking if it's a right triangle, which it is, of course, I want you to identify the given or the side length names. So what is x for the given angle? Actually, let's add that to this. For the angle. So 25 degrees is our angle. What is x compared to the 25? What's it called? Yeah, so x is opposite. What's the 12 called? Good. Okay, notice in this case we don't care about the hypotenuse. We're not going to use it. Number 3. Choose the correct ratio. So this is where SOHCAHTOA comes in. Savannah's boyfriend? Not yet. Not yet. It's coming. You could call him Toa for short. No? The quarterback for the Dolphins is Tua. It's not that different. His first name is Tua. Tua Tagovailoa.
That's a weird name.
He's from a Pacific island. He's a good dude, I think.
That explains that.
All right, so what is the correct ratio that we're going to use? With opposite and adjacent, so OA.
Tan?
Tangent, yep. I guess I should say choose the correct ratio using SOHCAHTOA and write the blank form. How do you guys, this form, what do you guys call that? I call it like the generic form or the blank form, but what do you have a name that you like to call that? It's not filled in, nothing's filled in. Okay, write the formula. Sure, let's do that. I really never have liked the word formula for these, but it's a common name, huh?
I just feel like it makes sense compared to everything else that we've done.
No, I agree. I'm saying that, like in math, formula just sounds like a science thing. Like we're a, what is it called? Like a mad scientist. All right, next. Fill that out. Fill out what you know. In the formula. What do we know in this case? We know opposite is x. It's not like we know its value, but we know it's x. Okay, what else?
the theta and
Good. So theta is 25, opposite is x, adjacent is 12. Good? All right, so from here, the steps kind of vary. Like this example versus the next example will vary a little bit. Our goal, though, is to just get x by itself. So get x by itself. And so I don't want to go into all the details, I'll just show you. Meaning, not like explain it all, because you guys know what to do from here, honestly. Like, how would you get that x by itself? What has to go? The 12 has to go. It says divided by 12, so what do you do to get rid of it? Multiply by 12. Okay? So this is going to look like times 12 times 12, and we're going to get 12 tangent of 25 equals x. Okay? Just that one single step. It will be, if your variable's in the top, it will be the same step every time. Just multiply by the denominator. Okay? You'll see that as you practice this. But anyway, what do we do to get this value? Because we don't want to just stop at 12 tangent of 25. We want to actually know what that is. So what do? Do you remember yesterday? Don't write this, but I'm just going to sketch the picture. We were talking about making triangles along this circle, and it traced out the curve, right? The tangent graph is super weird. I'll show you that here in a bit. But basically, all we're saying is what is the ratio between the opposite over the adjacent as we go around and change that angle. And that changes based on where this point rotates. But it's still a fixed set of values, or at least for cosine and sine. For tangent, it's not. But in other words, we have infinite values for that. But it's just, you just punch that in and get the value of that ratio. Okay? So grab your calculator. You need to make sure you're in degrees for this class. And type in 12 tangent of 25. Here's how that looks. 12, you actually don't need to push times, even though it is times. 12, tangent button is right over there by the division kind of sign. 12 tangent to 25, enter. And you need to make sure that you are in, I'm in radians. Why did it switch back? I switched mine yesterday. Oh, but I know why. My computer reset last night. Let me switch over. Alright, 12 tangent of 25. There we go. That makes more sense. We can't have a negative side like that.
So each time, like, if I try and click like the buttons of 12 and then I go and click tangent, just automatically.
So you're going to have to do tangent of 25. So do 25 tan times 12. And the reason why is your calculator's algebraic logic is backwards from these other ones.
So am I going to do that every time?
Yeah.
How do I know which one to put first? It
So
doesn't matter.
let's say it on yours, let's say it this way. Whatever number you enter, when you hit tangent, it takes the tangent of the number you put in before you push the tangent button, not after. So this says tangent of 25. If you typed it in exactly like this, yours is taking the tangent of the number before, not after. So yours would be tangent of 12. So you're going to have to reverse that and do 25 tangent times 12.
So I'll always do the second number first.
Well, I don't want you to just get used to that, but yeah, that's kind of the idea. All right, so 5.9, let's just call it 5.6, shall we? Okay. Okay, so last step. Didn't want that color, hold on. I'm going to put in here in big capital letters, make sure it's in degrees. That says something else. Yeah. Okay, so we get x was 5.6. Okay. Basically what that tells you, actually let me let you write because I want you to hear this. Okay, I want everybody to hear this. Everybody type in tangent of 25. Ignore the 12, just type in tangent of 25. Or yours would be 25 tan. Tangent, okay. Tell everybody what you got.
0.466.
Okay, so everybody says the same thing because the tangent of 25 is a set value. Okay, for a 25 degree angle, these two side lengths will always have the ratio of roughly 0.5. It was point what?
0.466.
Okay, 0.46. In other words, x is about half of 12. See that? 5.6, it's just a little bit less than half. For a 25 degree angle, that will always be true. Okay, type in tangent of 60. So don't draw this on yours, but think about a 60 degree angle. Okay? 60 degrees, that side is taller now, right? And this side is shorter. So tell me what the value of tangent of 60 is. Go ahead. Okay, so it's almost double. It's 1.7 times. So what would that be? 12 and then 0.7 is 8. So this would be like approximately 20 for a 60 degree angle. And that will always be true. It's always 1.7 times bigger than the adjacent side. And that's true all the way around our unit circle, or in this case for our angles all the way up to 90. Okay? Push tangent of 90. Uh-oh. What did it say?
Error domain.
You broke it.
This is error domain.
Okay, here's why. Do you remember that unit circle? 90 degrees is right here, right? So we're talking about this length, and tangent is sine over cosine. Well, that cosine value is 0, so you can't divide by 0. That's why it's telling you it's an error. Okay. Let's do this just for fun. You want to see something really wacky? Go to y equals. And you might have to clear what we put in there yesterday. I think we put sine in there yesterday. Instead, push tangent of x. And go hit graph. Did I put it in
Is
right?
that it?
It's not. Tangent of x. Zoom. Let's do zoom 7. Push zoom 7 so it shows us the trig graph instead.
Is that window?
There it goes. Our window is too wide.
Weird.
That's the trig graph, or the tangent graph. And it does that forever, all the way to the right and left. Did everybody get it to work? So did you do zoom? And then 7 is zoom trig.
Graph instead of invalid dimensions.
Do you have just tangent of x? Okay, I'm not.
So I was doing this yesterday with our
With
results.
sine?
Yeah.
Why don't you do a reset? Do you have anything in there you care to lose? So do second plus sign, and then hit 7, 1, 2. Then try, I don't know what's going on there. It's really itchy. And then go enter tangent, and you'll probably have to do zoom 7. Anyway, isn't it a weird looking thing? And it's because each time you get closer and closer to the next, where the denominator is 0, it blows up in both directions. So anyway, just thought that was interesting to show. Did it work?
I have a graph of this one.
Do Zoom 7. Did you?
No, I was asking what the cosine number was.
Oh, it is 27. Okay, so punch that in 14 over cosine 27. I forgot the over part. Real quick, if you're using these TIs, do you see how it opens parentheses right there for you? Get in the habit of closing those before you hit enter, because in law of sines and law of cosines that could mess you up if you forget. Okay, 15.7 for that. Okay. So those are the two versions of solving for side lengths using trig ratios. How's that seem? Okay. So a plane takes off and climbs at a 12-degree angle. Is that angle sufficient enough to fly over an 11,088-foot mountain that is 12.5 miles away? So I want you to think of it like this is really like what we live in here in Grand Junction. So a plane takes off from the airport and flies towards the mesa, which is about 11,000 feet. It's probably not exactly 12.5 miles, but it's not hugely different. So if they start at a 12-degree angle, are they going to make it over the mesa? Okay, that's kind of what we're asking. So you're just starting this problem by solving for x. So I'll talk you through the rest of it, but solve for x. Can everybody see the picture okay? Okay, so use that process we just practiced and wrote down to solve for x. All right, we have our picture. So we're given this 12. Let's identify what x is. What is that called compared to the 12? That's opposite. And 12.5, that's the adjacent side to the 12. So we have OA, which is which one?
Tangent.
Yeah, so we're going to write tangent is opposite over adjacent. So in this case, theta becomes 12. Opposite is x, and adjacent is 12.5. How do we get x by itself? Yep, this says divided by 12.5, so just multiply by 12.5. You can put an over 1 if you want. Like that. Okay? So 12.5 tangent of 12 is our x. And close that parenthesis, and we get 2.66. Okay, so that's, how'd you do on that part? Everybody got it? And you might, like if you're thinking back in context of the problem, like how does 2.66 get over 11,000? But what are the units of the 2.66? That's miles, right? So we need to convert, to answer the question that we're being asked, we need to convert from miles to feet. But that's not trig, that's just conversion, unit conversion. So if you got here, you're where you need to be for right now for solving trig side lengths, solving for side lengths with trig ratios. Okay? Does anybody, just to finish so you don't be left wondering, does anybody know how many feet are in 1 mile? You know Denver's the mile high city, right? It's kind of its nickname.
No.
Okay, it's 5,280 feet per mile. So we're in Grand Junction, we're 4,600 feet roughly here. So we're about 600 feet less, 700 feet less than a mile, but we're pretty close. So Denver's about 700 feet higher. Not like the whole expanse of city, but in general. So we just need to multiply this by 2.66. Go ahead and do that on your calculator, and then we'll be in feet, because this was miles. So how many feet? Sorry, how many feet is is that? How many feet?
14,000 and 44 feet.
Like that?
Mm-hmm.
So is he gonna make it over the mesa? I see faces. Is that not what you got? Oh. This is 5,280 times 2.66.
I got 1,984.
1,000? That's the thing, right? Because look, there's two of these. That's at least like 10,500. Okay, so it's probably good. Okay, now I'm seeing some head nods. Thank you. So is he going to make it over the mesa at 12 degrees? Yeah. Okay. Because he's going to be 14,000 feet and the mesa is 11,000 feet, so he's going to be 3,000 feet above it. He'll have plenty of room. No worries at all.